So is my screen visible?
Yes, it's visible.
Okay. So today my topic is perceptron algorithm, and this is the structure of single layer perceptron algorithm, perceptron network. So from this picture you can see that there are single layer in this network, and there are several inputs like x1 x2 up to xm, and there are several weights, and this is the summation part. So what it will do is it will just take the x's and it will multiply with w's and plus bias, so wx plus b, and then it will pass this summation to a function which is called threshold function in case of perceptron algorithm. So here you can see that fx equal to 1 if wx plus b greater than equal to 0, and it is 0 if wx plus b less than 0, and this is the predicted yp. So actually perceptron is an algorithm which is mainly used for binary classifier using this threshold function, but you can also use this for linear regression. So to use it as linear regression, you have to change this as identical function. So what it will do is it will take just fx equal to x. So if you remove this activation function, then it will act as linear regression. And if you take this activation function as a sigmoid function, then it will behave like a logistic regression. So you can see from this list that there are several activation functions and the equations of the activation functions and the examples. So if you take this phi z or fx is the same, so if you take this identical or linear function, it will act as Adalin or linear regression. And if you take the step function or this threshold function, then it will act as a perceptron variant. Like that, there are several activation function. For example, if you take this fx equal to 1 divided by 1 plus e to the power minus x, then it will act as the logistic regression. So here the only difference is the activation function. So if you use fx in different activation function, then this whole network will act as a different algorithm. So you can see that there are several activation functions like logistic, tanh, and relu. And nowadays, for multi-layer neural network, this relu function is used, which is already discussed in lab 4 of optimizers. So now let's start from the beginning. So here, suppose here the objective is given four features of a patient, which is age, weight, BMI, and skin thickness, and you have to predict the height, which is YP. So here YP and Y hat is the same. So here the dataset is XI and YI, and XI is the R4, means there are four dimensions of the data: age, weight, BMI, and skin thickness, and you have to predict the height, which is a real value. That is why it is regression problem. So first the step is define a loss function. So here the loss function will be mean square error, which is yp minus yi whole square. So yi is the actual class and yp is the predicted height. So yi is the actual height, yp is the predicted height, and you have to sum over all inputs, and yp it will pass through a activation function which is fx here. So yp equal to f of w2xi plus b, and f is the activation function. Then you have to optimize this loss function, which is summation over yi minus yp whole square divided by n, where n is the number of data points. So what is the meaning of the equation? The meaning is the to find the best w's for which this loss function, which is yi minus yp, or you can replace yp as the function of wt plus xi whole square, is minimum for all n or m data points. So as I said, if you use this fx as the identity function, so where identity function means fx equal to x, then it will act as the linear regression. And in case of perceptron, this fx is a threshold function, which is fx equal to 1 if w transpose x plus b greater than equal to 0, or else 0, which is binary classifier. So which is discussed in this example. And third step, and after second step, which is optimize the loss function, the next step is solve the optimization problem, or training steps. So this, from this onwards, which is already discussed in lab 4 optimizers chapter. So for optimizing it, you can use several optimizers algorithm like gradient descent, stochastic gradient descent, mini batch stochastic gradient descent, RMS prop, ADAGRAD, ADAM, etc. And this algorithm is same as the previous. So first of all, it will take a bunch of k examples from xi yi from whole dataset D, and then it will take the randomly initialize the parameters. So it will, at first iteration, it will take the random w's, and then it will repeat this process until w new equal to w old. And which, what is the equation is w new equal to w old minus eta d error by dwx. So it will first calculate the yp, and then it will calculate the loss on the number of inputs, which is here the loss is yp minus yi whole square, which is sum over all inputs. And then it will calculate the gradient of loss with respect to the parameters. So it will calculate the loss with respect to these parameters, and then it will update the equation w new equal to w old minus learning rate into gradient. And the process of finding this gradient is called backpropagation. And then it will update the w simultaneously, and when this w new equal to w old, then it will converge. And as I said earlier, that in deep learning most of the functions are non-convex, so those concepts will be taken from there. And then the chain rule of differentiation is used to actually calculate the derivative of the loss, which is already discussed. And now how to implement this perceptron is using sklearn. So in sklearn already there is a module called sklearn dot linear model dot perceptron, and there are several arguments, for example penalty, alpha, max iteration, shuffle, and eta. So for example, penalty has three arguments like L2, L1, and elastic net. And if you don't write anything, then it will take as none. So already L1 and L2 are discussed by Suraj. So L1 is lasso and L2 is ridge regression, and it is used to avoid the overfitting. So L1 is L1. It is L1 because it is just taking the absolute value of the magnitude. So you can see that this is a loss function which is yp minus yp whole square plus this lambda summation over bj. So this is the L1, L1 regularizer, and L2 is the square magnitude. So here the lambda beta z whole square. And elastic net, if you use either L1 or L2, so equation will look like this. This is the yi minus yp whole square, and if you just take both L1 and L2, and depending on the situation it will automatically take L1 or L2. So here you can say that this is the L2 and this is the L1, and this lambda 2 and lambda 1 is the hyperparameter. So you have to take different values and you have to see which one is the best. And then the next argument is alpha. So alpha is by default 0.0001, so which is a constant that multiplies. So here lambda is the alpha, so here lambda is by default 0.0001, so constant that multiplies the regularization term if regularization is used. So this lambda term is here alpha. And then maximum iteration is by default 1000, so it is the maximum number of passes over the training data set. And there is another parameter, I think shuffle, so which is take true or false. So if it is true, then it will shuffle the data and each and every epoch, and if you false, then it will not shuffle. And eta 0 is the learning rate. It is also a hyperparameter. So learning rate is the constant by which the updates are multiplied. So here learning rate means this term w new minus w old minus eta. This eta is called eta 0 in this sklearn implementation. And now this is the code. So to define perceptron using sklearn. So first of all, we have taken the data set which is already there in sklearn. So the data set has x and y. So and this is already implemented make classification. So there are several x and y's, and we have to predict whether it is from 0 or 1 binary classifier. So if you import this one from sklearn dot datasets import make classification, so it will automatically import it, and you don't have to download it. And then from sklearn dot model selection import grid search cross validation, and this grid search cross validation is used for hyperparameter tuning. So if you recall, in knn we have discussed the k-fold cross validation, so where k is the hyperparameter, and to detect the best value of k, this grid search cross validation is used. And here there is no k, but there are several other hyperparameters like learning rate and number of epochs, etc. So for that this function is used. And next the model is perceptron. So from sklearn.linear model import perceptron, and fourth one is the repeated stratified k fold. So how many numbers of fold you want to use, means k equal to 4 5 like that. And then you just import the dataset xy, make classification, number of samples 1000, number of features is 10, and out of this 10 how many of them are informative, 10 features. And that is why and n redundant means the number of redundant features, which is 0 here. And then random state. Then you just define the model perceptron, and then how many number of fold you want to use. So that is why this function is called repeated stratified k fold. So number of split is 10 here, then it will repeat 3 times, and random state equal to 3. and as I have said, that eta is this eta is a hyperparameter. So you have to choose the best one. That is why I have just taken several values of hyperparameter like 0.001 0.001 to see which one is the best, which is learning rate. And then this grid search cross validation function is used. So here there are several parameters like model means perceptron model, and grid means it will take this dictionary, and then scoring it will take the accuracy. It means for which eta the accuracy is the maximum, so that will be the best eta. And then cross validation equal to cross validation, it is means the number of k fold. So here the cross validation is repeated stratified k fold, so it is 10, so it will take 10 fold cross validation. And number of jobs equal to -1 means the it will take how many number of cores in your system, then it will automatically take it. That is why it is -1. Or if you know the number of cores you have, then you can take n jobs equal to 2 or 4 or 8 like that. And then you just fit it, result equal to search dot fit xy, and then it will automatically calculate. And in grid search cross validation there are these best scores, best parameters, cross validation results are already there. So you just call result dot best code, result dot best parameters, then it will automatically it will show you. And then you can see from this output that best accuracy is 0.857. And these steps 1 2 3 4 5, for 5 etas it just calculated the accuracy. So that is why the scoring is accuracy. And then it has taken the first one for which it is the best. So first one is 0.001, that is why it is saying that best learning rate is 0.001. And here it is so to take both these um, uh, accuracy and these parameters, this mean, and here is a function called zip for mean comma param. In zip means comma param. So what it will zip is, zip actually join two tuples together. So actually tuples are not modifiable or not changeable data structure in Python. So it will take means and params tuple, and it will combine it. And for this best learning rate it will calculate the number of epochs, best number of epochs. So where it actually in previously I have said that there are two types of hyperparameters, one is learning rate and another is number of epochs. So here you have to take in next you have to determine what is the best number of epochs. So for that I have taken the learning rate as 0.001 because it is already said that point for 0.001 it is the best accuracy. Then similarly for that you have to take several number of epochs for which this is giving the best. That is why number of epochs 1, 10, 100 like that. And the rest of the code is the same as previous. You just call this search equal to grid search cross validation. Model means perceptron this model, and then grid means this number of epochs, and scoring accuracy, and cross validation equal to cross validation means this one, this repeated stratified k fold, which is 10-fold cross validation. So here it will cross validation equal to cross validation and n jobs equal to -1. Then you just fit it, search dot fit, and similarly you just want to see for which number of epochs it is giving the best one. So it is giving for the 10, it is giving the best accuracy 85.7. So that's it. So now you have, if you have any doubt you can ask. Okay, then I think Sujay sir will present the next part.